Hi folks, so since my last video I got the redesigned boards for the Luxman here. First time I was so fixated on getting the spacing between the tube sockets that I ended up not even paying attention to the fact I had used the wrong sockets. So this time I got the right sockets. Now these are no-val sockets. Tube sockets are, as I said in the last video, given names, not alphanumeric identifiers. So once I got that, you can see in this picture here that the tube sockets fit. I think this thing's going to work. I was doing some video on this. When I glanced at the camera, I saw the message memory card full. I got disgusted and just formatted the card and lost the video that I had done up to that point. This is the problem with getting out here early in the morning. When it's bright and early, I'm not bright when it's early. So, in any event, this is kind of a preamble for some video I've already shot. I'm going to put some signal through here, which really doesn't tell us much because this is a completely passive path, and even before I repaired the power supplies, we should have been able to get signal through. But I want to make sure that there's signal getting to the driver card, because that's the next frontier, and I think it's going to be fairly rough. I also believe, although I don't know for sure, that the tube board is an integral part of the driver, because the tubes are actually the second differential amp in the circuit. A lot of people think that they are some kind of preamp. They are not. They actually are part of the driver circuit itself. So I'm going to have to wire one side in at least and see what I can get going here. But the driver board needed a lot of work, and as you'll see in the upcoming videos, there were several problems I've already found. So let's get to it. Okay, got this thing fired up. We have a power LED indication. We have our function indication. We have some other controls here. If we turn them on, we get indications there. The signal path is completely passive here, so we are good up to that point. So the next thing we're going to look at is the driver board. But I do have signal going all the way. If you look at the scope and I turn the volume up, you can see we have signal. And if I do the other channel, let's see, I think that's left. That's right. So we're good up to the driver board. So we're going to take a look at the driver board because that's going to need a lot of work. And amazingly enough, the tube boards came in today. And these look like they're going to work because I was able to mount the tube sockets on here and get the capacitors in. I'm not going to bother. I didn't bother with connectors because they melt on here anyway from the heat. I'm just going to wire these directly, but I'm cautiously optimistic that this is going to be a good solution. And the tubes, again, at least I got the spacing right because it looks like the tubes are going to lay in the housing the way they're supposed to, like so. I think they're going to be somewhere like this, so they'll show through the front. You'll be able to see them glow. And yeah, I think we have a good solution. So let's get to that driver board. It's going to need quite a bit of work, as I mentioned. All right, this tube board has been exposed to a lot of heat. It looks like a lot of it's coming from these resistors here, so I may replace them and elevate them from the board. No need to do even more damage. These heat sinks I got that I tried to use on the regulators won't fit through the space constraints, but they should be just fine here, and they slide into place like so. And I think that'll be a good solution for keeping the heat on these away from the boards. Most of this looks like it came from these resistors, so I don't know why they didn't mount all of them like this. I don't know if that's factory stock, but I have to assume it is. But we're going to elevate these. Looks like some of the resistors chipped away there. I replaced these two electrolytics that were the only ones on the board, and I have to replace 6 here, 2 here, and I believe there are a couple of polystyrene I'm going to replace with I think I have to look and see what I got, but I got some replacements for those. So we'll see what we got here after I get done working this board, and we may be trying to get the tube board hooked up too. We'll see how long this takes. Okay, so I'm going through this board. There's 2 LEDs here, I believe, set the bias with a couple of transistors. We'll look at that schematic in a minute. One was lit and one wasn't. So now, are they supposed to be lit or not supposed to be lit? But I did find a problem. I was checking the resistor string. This would be a good time to look at the schematic. So we have an LED here, and it goes basically between the base and emitter of this transistor, and it should set the bias here, and it goes through 22 or 20K resistors, so it's 22, 42, 62, 82, 102, 122, 142, 164 to the cathode up at the top of the other LED. So it's basically a string, and I should be able to measure from one cathode to the other cathode and get about 160 ohms, or 162K ohms, I mean. And what I found was, as I was probing one of them, I noticed, let's see, I think it was this one, or was it? I think it was this resistor right here, and this may be really hard to see. You see the motion right here. Look closely as I wiggle it. See how that's moving? Right there, that's a broken solder joint. When you just look at it, it doesn't look all that bad, but these can be devilishly hard to find. So we're gonna see if we reflow it, or we might have to run a small piece of cut component lead between here and here. Okay, so I've reflowed that solder joint, and now let's see if I can do this without knocking the camera too bad and actually getting the meter in here. I'll move back so you can see what I'm doing. Should still be able to see that meter. But if I measure from the cathode to the cathode, there's our 162K. So we had a break there, and I think that was causing the one LED not to illuminate. I think they're both supposed to illuminate. So let me put this together and we'll see what we get. Okay, so we have our LED here and here, and now when I fire it up, we get our LEDs illuminating. Now, I don't know if this is going to actually pass signal without having the tubes in there, because a lot of people seem to think that the tubes form the preamp or part of the preamp stage, but they don't. They are actually a second differential amplifier. So they may have to be in the circuit to get any signal through here. I just want to make sure that nothing here is really badly out of whack before I start thinking about wiring those tubes in. So now that these are both lit, I'm going to check to see if voltages are equal left to right, spot check a few of these, and if everything looks okay, I may start to wire that tube board in. Still not exactly sure I'm going to mount it, but you got to take this thing one step at a time. Well, as I said, the driver board is going to be a challenge, and so far it hasn't disappointed. I've found some more problems with it, but at this point I'd like to step back a little bit and take a block diagram overview of how this thing works. Now, this is a little different than a lot of more conventional amplifiers, so I just want to break it down into a few simple blocks. So as you see here, this is the entire driver stage, including the tube stage, which, as you see, they have marked as the second differential amplifier. The first differential amplifier is over here in this section. And before that, on the left-hand side of the schematic, you have something they call the V stabilizer. And what that really is a voltage regulator. So we have a section here on the left which is really just voltage regulation, and you'll have at the top half positive regulation, at the bottom half negative. And next to that we have the actual driver stages themselves, and they kind of demark here to left and right. So these are essentially the 3 blocks that we have on the driver board. And as I said, the tube stage is an integral part of this whole thing. Now, something I do when I'm working on an item like this is I will take a section, whatever section I'm working on, and copy and paste it in the paint and put the expected voltages at various points. Some schematics already have these, which is very convenient. This one didn't. And I did them in red. I normally do them in blue, and then I'll take a red marker and just write what I get so I can compare it. But I did them in red. I thought it would show up better in a video. It doesn't really matter for what we're doing. But anyway, I'll do that and I'll start looking at it, and it becomes very clear then where your problems lie. And one of the first problems I found was my regulators weren't working. I was getting basically 130 volts all the way around at all 3 terminals of what we refer to as the pass transistors. In this case, we're talking about a Q1101, Q1102, the positive and negative pass regulators, series pass. And I started checking them. What I discovered was I had several bad components in here. So Q1101 and Q1102 were both bad. And also ZD1103 and ZD1104, they are 36 volt Zener diodes, half watt. They were both shorted. And also what they call the buffer amp, the one that connects directly to the Zener, Q1103, Q1104, also bad. So I'm going to move the camera so you can look at these, and I'll show you what the failure modes were. Alright, so these are the components I got out of here. These are our series pass transistors. These are our buffers. Here's one of the Zeners. The other one got lost, and they were both dead shorted. In fact, we'll just start with those, and you can see and hear that's shorted. Now, you need to know what your pinouts are. This is where your data sheets come in handy. These pinout emitter, collector, base. These pinout base emitter, collector. In any event, I really liked the older method of doing this. You always knew at a glance that your green transistors were PNPs. So, knowing that pinout emitter, collector, base, we check this one, and the emitter and base junction is open. The base collector junction is shorted. We have to switch the leads for our NPN, but we have the same failure mode. Emitter base open, base collector shorted. Okay, this is base collector emitter. Okay, that looks and sounds good. Okay, this transistor looks good. All right, so base collector good. Base emitter good. Reverse our leads here. Base collector good. Base emitter, remember you only want it to conduct in one direction. But watch what happens when we go to our collector and emitter. I'm just going to go to the tab here for our collector. Dead short, emitter collector. I didn't bother checking these other ones because they were already bad. And last one, this one is NPN. So we're going to put our red lead on the base. Okay, that's 0.38 volts. That's not good. That's 0.22 volts. Also not good. When we reverse them, we shouldn't get anything. We got 0.38, 0.22. This is a bad transistor. Base to emitter, also not good. So all 4 of these components were bad, and once I replaced them, our voltages started to look a whole lot better. We're going to take a look at that. Oh, by the way, I need to mention, when I replaced the Zener diodes, I did not have 36 volt Zeners. I put in 39 volt, I will replace them, but I just wanted to see if I can get this thing up and running. Okay, so we have a problem with our positive supply, and I'm going to show you what that problem is. Now, recall, we should have positive and negative 99.9, call it 100 volts. So we have our negative 99. 99.9 to 100, that is perfect. But when we look at our positive, we now have 100 volts, and I'll show you what the deal is. I didn't fix it. In fact, let's see. I can probably make it malfunction again. Okay. I don't really want to stick my hands in here because I got a shock yesterday. First time in a long time I got myself shocked. It was off the collectors of one of these guys, 135 volts. To say it got my attention would be an understatement. I could have skipped the afternoon coffee after that. Let me see if I have a better tool for that. The problem is a broken solder joint. Now while I would see, now we have 59. If we poke around the zener here, yeah, we can change it. I'll show you how I figured out where the problem is. So we're going to take a look at the schematic and then we're going to fix it. We should have our power supplies up and running. All right, so here's the schematic. And if you take a look, we've actually got two zeners here. One of them is going to set the voltage at the base of this differential amplifier here. And it's going to set it, it's a 36 volt zener, it says 37.4, should be somewhere in that neighborhood. And it was not, because we had a broken solder joint between here and here. Probably happened when this capacitor was pulled out. I didn't pull this one out, but I did replace it, and it may have been weakened from when it was taken out because whoever worked on this last didn't do a very good job with a lot of this stuff. But in any event, this is where our problem is. It's right up in here. Because we didn't have our reference here, we weren't able to get our base set here, because our base is supposed to be around positive 62.5 volts. Added to the 36 volts of the zener should get us about 100.5 here. Diode drop across the series pass transistor should yield 99.9. So the problem was we weren't getting our proper reference. So I'm going to repair this. I'll take a quick close-up picture of it and post it on the screen, and then we'll go back and you'll see, as you saw, that we'll have both our supplies. Then we're going to start going through and spot checking some of the other voltages, see if all the voltages are good through here. And if we can get that straightened out, we'll see if we can push some signal through. Okay, so I repaired that trace, and here's some pictures of it. You can see there was a bad solder joint here. It may have happened when that was removed or when I replaced the missing capacitor, but in any event, we should have our positive and negative 99.9 100 volts. So our negative still there. Now our positive is there. So our voltages there look good. So our voltage regulators are good. Hopefully that means the rest of the voltages throughout here are good. Now I'm not going to check every one of these. I do want to see what we have leaving the amplifier. Because if everything else is good, we should have at the last transistor in here that goes to the tube PCB, we should have negative 2.4 volts at the emitter and negative 3 volts at the base. If we have that, we have a chance that there's actually voltage going through here. So I'm going to check that, see where the best place to get it is. It looks like, well, let me see, is that the back or the front here? That looks like the front, so here's the emitter. The emitter is negative 62 volts. We got a problem here. We're going to have to see where that is. In order to have the correct voltages at that last transistor, we also need to have voltages coming from the output stage. Now, there's no output transistors in there, but there are still connections. And it started me looking at a few different things here. One of the things that started me looking at is I don't see that this is stock. Somebody spliced some stuff in here. I'm not sure how or why. So I got to check the continuity and make sure these are going where they're supposed to go. But I found yet another problem with the board. And while I had considered reflowing all the solder joints on it, I really don't want to do that because the board is in such poor condition. I may wind up having to do that anyway. But what I'm going to show you now is I'm only working on one side of this. I just want to get one side up and running. And what I found is, as I'm starting to check, I wanted to check the continuity on the pins that go through the board here to the back. The first one I checked, I have no continuity through the pin to the back of the board. I'm not sure how that can happen. I can see it. If I go here to this pin and to the back of the board, now I have continuity. I did not before, so I am going to have to reflow these. And we're going to have to check the connectors. Now if I plug this in, I'm going to check from the back of the board to the other end of the connector and see if we have anything there. Okay, that one looks good. I'm not sure what order they go in because they kind of change as they go through the board. And let me put my probe extender on there. Make sure I can get down in here. Okay, that one looks good. Next one. That looks good. And the last one. That looks okay. Now I have to make sure they go where they're supposed to go as well, so we're also going to check that out. I may wind up reflowing this board because there's definitely some problems here. I did at one point have low voltage where I'm getting negative 62 instead of negative 2.4. This thing's got a lot of issues. I knew it would going in. I think I may at least reflow some of the suspect solder joints, see if any of this other stuff's moving. Well, we knew it was going to be a job, and like I said, it has not disappointed thus far. Okay, so I reflowed the connectors, the solder joints on the connectors, and I'm verified that the pins go where they're supposed to go down on the main board. So now I'm going to turn it on. I am looking at the base of Q7109, and we're supposed to have negative 3 volts here when this circuit starts up, and we don't, which is perfectly normal, and I will explain why that is. But I'm going to turn this on. You can see we have a positive 68.7 volts and not a negative 3 volts. Okay, now as the tube warms up, and it takes a few seconds for this to happen, we should see our voltage start to drop rapidly. There we go. So the tube warms up, and as it begins to conduct, it brings more of the negative voltage in. Now this is supposed to settle out at negative 3 volts, but it doesn't. And I believe the problem, although I'm not really sure, if you'll recall, I've always said that if you find a problem, fix it. You may not think it's related, but more times than not, it is. Okay, so as the tube warms up, it's conducting. Our voltage is starting to swing negative, which is good, but it never makes negative 3 volts. This is about as good as it gets. Now, if you recall, I didn't have any 36 volt Zener diodes, so I put in 39s, which is what I had on hand. It was the closest value I had. So Each supply, negative and positive, has a 39 volt Zener and not a 36 volt. Now the voltages coming out of the regulators look good, and I fail to see how this is the problem, but I would rather have the right parts in here just to eliminate that as a possible cause. So I may have to set this off to the side so I can pile another Mouser order, because I hate paying $10 shipping and handling on $2 worth of parts. So we're going to go over the schematic. I'll show you why this works the way it does. And then I'm going to have to call this video done for right now. Anyhow, when we first turn on this amplifier, the tube is cold, and we have 95 volts at the grid of the tube and negative 92 volts at the cathode. But the filament's cold, and it's not emitting any electrons yet. So instead of having negative 3 volts at the plate, we have a positive 67 volts, because coming in through these resistors right here, R7139 and R7141, two 27K resistors, they connect to the to the positive 99.9 volt supply. So while that tube is cold and not conducting, we have at the base here positive 67 volts. Once the tube begins to conduct, it begins to bring the voltage down, because the cathode is at negative 92 volts, and it's supposed to settle at the plate and the base of Q7109 at negative 3 volts, but we're not getting there. And I really believe, or at least I want to eliminate those Zener diodes as a cause. So this is going to have to conclude the video. We're already starting to run long, and as always, thank you for watching, and I like giving back to the community that's given me so much. Thanks a lot, everyone.